Hi, I'm George Zush, and I'm here to show you how to use orchestration with WPS and Taverna. This second video going to show you how to use a mapcalc module from GRASS.js. I have here a WPS that has a service called r.mapcalc. This is a front-end service to the mapcalc service from GRASS, and it was ported by Sorens in the WPS-GRASS-bridge project. I have here raster inputs from to the service, and we have something like 8 rasters that can be inputted to the service. Also, as an input to the r.mapcalc service, we have here math, that is basically a way to pass equations to the service, and we have the output that we desire. So I'm going to show you, I have here already one workflow from a previous video. Here we have my instances, and this workflow simply transforms a TIFF image into a PNG image, so I can properly see it in Taverna. And I have also here another workflow, that's the watershed workflow, that generates accumulation images from dams. This is basically images with accumulation of water flows, and I'm going to process this image in mapcalc using the r.math WPS service. And so I'm going to import those workflows. I'm going to import just one workflow now using the nested workflow functionality. I'm going to import the watershed workflow. It appears like this. It's relatively big, so I'm going to hide it, so it appears as just one box, as one service. I'm going to rename it. This is my watershed workflow. I'm going to get a water accumulation flow image from this service, and for that I need to pick it up an input. Okay, I'm going to pass it to the service or workflow. Okay, and now I'm going to use r.map to run a calculation on the return image. I'm basically going to cut any pixels that are below a certain threshold, and I simply have to check the inputs, and I'm going to say that my image is one input to the service A, and I'm going to write here an equation that is related to the output and to the raster input. So I'm going to write output, which is the name of my output image, and I'm just going to say if my input image, which is A, is bigger than 100, then I'll get A, otherwise I'll get a null value. This way I'll cut any pixels that are below 100. I'm going to see why I need this. Okay, so now that I'm going to have an image, I need to transform it to PNG so I can easily see it inside Taverna. Here we go. I'm going to pass the r.math output to this service. Okay, and I'm going to add an output port. Okay, I'm going to connect it, and again I'm going to get the image TIFF to PNG so I can compare both images before the r.math calculations and after the math calculations. So I'm going to connect to these and everything to the output port. So I'm going to have two images to compare. You're going to see why I'm using r.math calculations in the TIFF image. Okay, it's running. It's going to take some time. to zoom in. Okay, the first workflow is being run. So I'm calculating the watershed accumulation image. Simply going to have some flow path. Okay, just have to wait a bit. Okay, it's going. This is all done remotely in my virtual machine that's in PMLs. So it's back and forth between all the services. Okay, first workflow has finished. Now we're going for the other two workflows. See, it seems that r.math is being calculated. Okay. Just have to wait. Oh, it seems that one services of geotiff2png is being run also. Just have to wait a bit longer. Shouldn't be taking longer. Okay, one workflow has been concluded. Going to see the image. This is my accumulation image. It has all these blue areas that I'm removing using the r.math service, and it shouldn't be taking much longer. Okay, everything has been concluded. As you can see, this is my image after r.mapcalc, where you can have a clear perception of the workflow, of the flows, since I removed the pixels that were below 100, and here's the original image and here's the calculated image, so you can see a nice comparison between the details. Okay, I hope you enjoyed this example, and thank you very much for your attention.